Hi, today I'd like to answer a question that was asked on YouTube, which is, can you explain how PP3V42, the power supply, works? How does this work? Will it be powered? Will it work if PP-BUS G3 Hot doesn't work? And I want to explain a little bit about what makes this power line different from other power lines in the computer. I'd also like to take an opportunity to answer some of the questions that I find to be kind of legitimate or not the same crap over and over again. For example, if you say, how does PP3V42 work and will it work if PP-BUS G3 Hot is not there? You actually have a fighting chance of your question getting answered. However, if you ask me, hi, where I get schematic, no. Anyway, so let's talk about this power supply. Let me answer you. Yes, PP3V42 will be present even if PP-BUS G3 Hot is bad. Even if that power line is 0 volts, you should still get PP3V42. PP3V42 is one of the few, if not the only, power lines in the machine that is actually independent of PP-BUS G3 Hot. PP-BUS G3 Hot is a standard 12.6 volts in the case of a standard MacBook, MacBook Pro, or MacBook Pro Retina. And PP-BUS G3 Hot is a standard 8-point-something volts on the MacBook Air. So, this is the main highest power line in the computer. That power line is a steady, nice, smooth 12.6 volts that will get used to create power for everything else in the machine. So the 5 volt line, the 3.3 volt line, everything else on the machine is going to get created from that. The CPU power, MCP power, power for the GPU, power for everything is going to come from that PP-BUS G3 Hot line. So if you don't have PP-BUS G3 Hot, you will have nothing. But the one thing you will have is PP3V42 underscore G3 Hot. The PP3V42 line is unique from every other line on the machine in that it works independent of PP-BUS G3 Hot when the charger is plugged in. It will actually work directly off of the charger. So while PP5V-S5, PP5V-S3, PP3V3, S5, and S3, power for everything else is created from PP-BUS G3 Hot itself, which is created from the charger. PP3V42 is directly created from the charger, and I'm going to talk about that from this little diagram that we have over here. So, let me just move this over here and start showing you on the screen what it is I'm talking about, and hopefully my PDF reader doesn't freeze and make me look like a moron. So let's look for PP3V42, and I'm going to use this broken clutch cover that I found on the floor as my pointing stick, so I can help be a better instructor. So PP-BUS G3 Hot is right over here. So the question was, can PP3V42 be created if PP-BUS G3 Hot is not there? So this is PP-BUS G3 Hot, right? This is the power supply that's going to many other parts of the machine. So this is sent over here to create CPU VTT, which is PP1V05. PP-BUS G3 Hot goes over here to create P5VS3. PP-BUS G3 Hot goes over here to create all of these different things. Backlight, RAM power. But what it doesn't go to is over here. So this is PP3V42 underscore G3 Hot. So this over here is actually PP3V42. Now, if I go to the left of V out, which is the output of the chip, which is PP3V42, if I go to the left, you get the input. The input of this chip can come from one of two things. Let's look at what the two things are. Let's follow along. So on this line over here, we have PP18V5 underscore DC underscore con, which is 18.5 volts from the DC charger, which is your MacBook Pro charger, and it comes right down here to AC adapter in. So this should be fairly simple. So the AC adapter, the AC power, so you have the AC adapter here, it sends the power down here, and that power goes directly to that chip. So that is not powered off of PP-BUS G3 Hot, it is powered directly from the charger. So to answer your question, you do not need PP-BUS G3 Hot to be present to have PP3V42 if the charger itself actually works and is plugged in. Now let's talk about off of battery power. Now battery power is in it of itself PP-BUS G3 Hot. So let me scroll down to where the battery is so I can show you how this whole thing works. Now, PP-BUS G3 Hot, as I said, is the main power rail that the system creates. So that's what allows it to do all of the work. Now, here's PP-BUS G3 Hot. This is created by U7000, this ISL6259 chip. This chip is going to control these two transistors. These two transistors are taking power from the charger and sending spikes of it to this inductor. What's going to happen is those spikes of that inductor are going to get smoothed and turned into 12.6 volts for the system. Now, if this is if there's no charger, if there's no 18.5 volts present, if there's no charger because this is not plugged in, and that chip itself is powered off of the charger, how are you going to get PP3V42 off of battery? Well, that chip has two inputs. It can use either the charger or it can use PP-Bus G3 hot if the battery is plugged in. So the battery actually becomes PP-Bus G3 hot when the charger is not plugged in. So you have over here, to and from battery. So through this transistor, and as I've explained before, a transistor is nothing but a resistor whose value changes based on an input signal. So this resistor will become 0 ohm and open completely and let the power from the battery go through here. And again, it's just following the line. It goes through here, it goes through here, it goes here, and then it goes over here. And this is where PP-Bus G3 hot goes to the system. So let's go back up to that first page. Let's go over to U6990 and let's talk about how this works. So let's say that this charger voltage is not here. Let's follow down on the second input. The second input comes from here. It goes down over here, goes down over here, and then goes to PPV bat underscore G3 hot underscore con, which is that connection that I was telling you. So if the battery is plugged in and has enough power, it will provide PP-Bus G3 hot to PP3V42's chip, which is U6990, which creates PP3V42. So to state it simply, you do not need PP-Bus G3 hot to be present if you have the charger plugged in to create PP3V42. However, PP-Bus G3 hot must be present to create PP3V42 if the charger is not plugged in, meaning the battery plugged in has to actually provide power to U6990 in order for it to create PP3V42 if the charger is not plugged in. Now, even if this chip, even if this U7000 chip that creates PP-Bus G3 hot is blown and destroyed and sodomized and never coming back, you can still get PP-Bus G3 hot to appear by plugging in a battery. Because the battery, again, the battery itself doesn't have anything to do with this. The battery has its own 12 volts. The battery doesn't need this to create, the system does not need this to create 12 volts for it when the battery itself is producing 12 volts for it. However, if you have a short to ground on PP-Bus G3 hot, if there's a short to ground on PP-Bus G3 hot, then when you plug the battery in, you're still going to have 0 volts because the battery power is going to be shorted to ground and the transistor is going to close if it sees too much going through and you're not going to get any power. That's how this is going to work. So, to answer your question, you do not need PP-Bus G3 hot to create PP3V42. You can have a charger create PP3V42. If you plug the charger in and you actually have this power going down the line to that chip and you don't get PP3V42, it has nothing to do with PP-Bus G3 hot being there. I would actually troubleshoot PP3V42 before I troubleshoot my PP-Bus G3 hot problems because I want to get a green light in order to actually give an idea of what is working and how much misery I'm going to be going through in order to fix the system. So one of the things that I talked to you about is how I want to know exactly what I'm in for from the earliest possible state. I want to know how much misery I'm in for, and I want to know what systems work and do not work, so I know what I should be paying attention to as I go. So I want to troubleshoot this power supply first. So if I plug this in, and I do not have PP3V42, that is the first thing I'm going to fix. I'm not going to fix PP-Bus G3 hot before I fix PP3V42. I want to show you a little bit about what actually fails with PP3V42's power supply. So the problem with PP3V42 failing is not anything to do with PP-Bus G3 hot. Again, it's really not anything to do with PP-Bus G3 hot. The common failures are as follows. The first is this inductor. So this inductor right over here is very often the problem. And also, while I'm here, I might as well show you how some of this actually works. So, this is a pretty basic kind of switching power supply. Very, very basic. So I just plugged it into my working board over here, and I'm going to show you on the oscilloscope what happens before and after the inductor. And I'll zoom in so you can see. Alright, so here is before the inductor. Now keep in mind how this is set up. Each one of these lines going up, each one of this line, and this line, each one of those lines is set to 5 volts. So keep that in mind when I show you this. So I'm going to, so here's the beginning of the inductor. And you can see it says voltage RMS is 7.4 volts, and you can see that I have spikes at around 16 or 17 volts. So the spikes are at least 3 lines in, which means it's above 15 volts, but they are actually spikes. It's not a consistent voltage. So if I do this, if I zoom in enough on the timeline, you can see that it's power, then no power, power, then no power, power, then no power. This is the basics of how a switching power supply works. It sends power, then it sends nothing. Then it sends power, and then it sends nothing. Then it sends power, and then it sends nothing. Now on the other side of this chip, here's what you're going to get. When I say chip, I mean inductor. So what the inductor does is it takes all of those pulses, and this is what you get. There's an inductor, which is going to do some smoothing, and then there's also a capacitor going to ground. A capacitor usually can only pass AC, which means it's going to send all the spikes and all the ripple to ground. So when you pass all those pulses through an inductor, which can only pass DC, and you send all of the junk to ground via a capacitor, all that flippity-floppity waveforms, this is what you get, which is a nice, very flat actually here it's reading it as 3.5 volts instead of 3.425. Let's see if you get a more accurate reading if I do this. Yeah, so now when I move the oscilloscope in, I get 3.38 volts, which is fairly accurate. It's going to work just fine. You have nothing to worry about. I also don't have a lot of trust for this oscilloscope because this oscilloscope was fairly inexpensive. So that is how PP3V42 works. That is how the power is created. And just to show you the capacitor on the line and the circuit just one more time up here. So this is input power going over here. So this is input power going to the chip. This is power going out of the chip. This is the inductor on output. And over here is a capacitor to ground. And this capacitor to ground is going to help smooth it out. And that is the output to the computer. So that is how that supply works. Now, let's talk about reasonable points of failure. What's actually going to happen? Why is my PP3V42 not working? Now that I've established that it should work from the moment you plug the charger in, and that this has nothing to do with PP-Bus G3 Hot, let's talk about what's actually going to fail here. Again, this channel is not just about theory, it's about practical reality and applying that practical reality so that you can make money. So let's talk about this circuit a little bit more. So, one of the first things that very often goes is this actual inductor. So this inductor will stop working. So you will see the pulses on your oscilloscope over here. So remember when I was showing you the pulses of 15 volts? You'll see pulses here, but you'll see 0 on output. When that occurs, you should check for a short to ground. The way you check for a short to ground is you put your multimeter into resistance mode, you put one end of the multimeter on ground, so one of those screw holes in the board, and you put the other end on here, where PP3V42 is, so right on pin 2 of that inductor. If you get a 0 ohm short or a really, really low reading, that means that something on the line is actually shorted to ground, and you will have to try to find it using either your brain or by injecting 3 volts into the line and seeing what gets hot. Now, one of the things that also happens here, sometimes you may get lucky and it may just be this inductor. Sometimes the inductor may have actually blown because there was a short to ground on the other side. Again, this chip, it can fail, but I have yet to see it fail. I can't remember replacing one of these where that chip was the actual problem. And again, one of the things I want to combat on this channel, one of the things I want to combat in general in this business is people just keep going, hi, I don't have this power line. What chip controls this power line so I can buy and replace it? You're asking the wrong question. The right question to ask is, hi, how can I go about troubleshooting my problem so I can replace what is actually damaged? Because again, this chip, this is one strong chip. That chip does not go bad. I have yet to see this thing go bad. So one of the things that I would do to troubleshoot it, remove this inductor. Measure for a short to ground on either side. If there's no short to ground on either side, put the inductor back on. And if there is a short to ground, find out where it is. So, Some of the things that may short to ground are little ceramic capacitors. There are a lot of capacitors on that line, and sometimes one of them breaks and goes to ground. Another thing that screws up on the older boards is the MCP, or as most people commonly mistakenly call it, the GPU. So the graphics chip on this board is not just a regular standard NVIDIA graphics chip, it is actually an MCP that controls many other functions of the board, one of them being clock signals. So if the components that are responsible if the components in the machine and inside the die and everything that are responsible for creating the clock signals are actually shorted to ground, it will short the PP3V42 G3 hot line a little bit, and that's one of the ways that you can tell that the MCP inside your machine is bad. So there are many things in this schematic that can cause PP3V42 to not work. The most common one, again, it's not the chip itself, and it's definitely not PPE bus G3 hot. The common faults are the inductor has gone bad, or a ceramic capacitor on the line is bad, or your MCP is bad, and any one of the components that is actually powered off of PP3V42 has shorted to ground. These are all things to explore, but PP Bus G3 Hot is not really where to look. So hopefully I've helped you. Hopefully you solve your problem on your board. Hopefully I've answered your question instead of just ramble on and off for 15 minutes. And good luck.